Afternoon, guys. Here we are finishing the week with the second stage of respiration. And this is a nice, easy finish to the week. We're talking about the link reaction, which is, unlike glycolysis, a single reaction, which links glycolysis to the Krebs cycle. So our learning outcomes for today, you're going to be able to describe the second stage of respiration. This stage of respiration has moved into the mitochondria. So remember, at the end of glycolysis, we ended up with 2 molecules of pyruvate, which were small enough to be able to pass across the mitochondrial membrane. So now we're in the matrix of the mitochondria, which is full, handily enough, of all the enzymes and coenzymes and other substances that are required for the link reaction and the Krebs cycle, which is the stage that follows it. So basically, the whole purpose of the link reaction is to convert pyruvate into acetyl coenzyme A, which is the molecule that feeds into the Krebs cycle. So what's going on? So pyruvate is decarboxylated, so carbon is removed. So we've got decarboxylation. Remember, this is one of the enzymes you need to know about, decarboxylase. It's then oxidized. Remember, it's losing electrons. Another word for that is dehydrogenation. And that leads to the production of NAD reduced or reduced NAD. Then the product of this reaction is attached to coenzyme A to form acetyl coenzyme A. So let's have a look at that in a little bit more detail. There we go. Sorry, it took a while to get there, didn't it? So remember, pyruvate is a 3-carbon compound, okay? And this is it. This is the nicest, most simple bit of respiration. So we have our 3-carbon compound, pyruvate, which is decarboxylated. So we lose CO2. Remember, you breathe this out. This is one of the waste products of respiration. This is what you breathe out, okay? That pyruvate is, after it's been decarboxylated, is then oxidized, which leads to the production of reduced NAD. At this point, the acetyl, which is produced by the decarboxylation and the oxidation of pyruvate, is attached to a coenzyme called coenzyme A, and this forms the 2-carbon compound acetyl-CoA. So if you remember back at the beginning, I said we need to count carbons. Well, here we go. Our 3 carbons becomes 2. But really important, remember when we entered the link reaction, we entered the link reaction with 2 pyruvate molecules because each glucose molecule produces 2 pyruvate molecules. So when we're talking about the link reaction, and indeed anything after the link reaction, we have to double all our numbers for each glucose that we get. So in the link reaction, our total is 2 molecules of pyruvate going in. And because we've got 2 molecules of pyruvate going in, we're going to end up with 2 molecules of acetyl coenzyme A, 2 molecules of reduced NAD, and 2 molecules of CO2 coming out. Okay, so this is one run through the Krebs cycle. Sorry, not through the Krebs cycle, one run through the link reaction, but this will happen twice for every molecule of glucose that has entered respiration.